Right, so our first objective of this chapter 3, according to our chemistry syllabus, is that you should know the formula of the elements and compounds which are named in the your subject content, right? Regarding different chapters, we should know what is the formula of different compounds and what are the ions, right? So, for example, we just say that the symbol of this element sodium is Na, right? Symbol of chlorine is Cl and so on, right? It's similarly magnesium. And if we are just going to write on the formula of suppose any ionic compound, or for example, sodium chloride, so it's going to be NaCl. And if it's going to be magnesium chloride, then it's going to be MgCl2, right? Do you know how and why those? Do I need to repeat it?
No.
Okay. Let's see if say that magnesium is in group 2, so we write down 2 over it. Chlorine is in group 7, so it gains 1 electron, write down 1. These valences are cross multiplied, so therefore the formula of magnesium chloride will be MgCl2. Similarly, if there could have been aluminum chloride, then it could be AlCl3. Okay. Now, the next objective of is that to find the molecular formula of a compound. What is the molecular formula? Like if I'm saying that the molecular formula of glucose is C6H12O6, right? C6H12O6. This is the molecular formula of glucose. So we should know what is the definition of molecular formula, right? And we can easily write down this definition in our own words. And how we're going to calculate the molecular formula, we'll also be doing this in the next class. Okay? But right now, we just need to know the definition of molecular formula, right? So what is a molecular formula? It states the number and types of atoms present in one molecule, right? For example, molecular formula of glucose is C6H12O6, right? So we can say that state the numbers, that what numbers are there, like how many numbers of carbon are there, how many numbers of hydrogen and oxygen are there. So we're going to say that the molecular formula of a compound is the number and types of atoms, right? Types of atoms like 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of oxygen, right? So it states the number and types of atoms present in one molecule, right? And types of, even you can say different atoms if you want to add that. In one molecule, right? It's known as a molecular formula, right? For example, if I'm writing the molecular formula of methane is CH4, right? So what is the molecular formula? How are you going to define Assalamu alaikum, Ania? We're just starting the third chapter, that is stoichiometry, right? In this, we just discussed that you should know the different ions and then the symbols of different elements, right? And the formula writing, okay? Then I was just defining molecular formula, right? So the molecular formula states the number and different types of atoms, right? And types of different atoms in one molecule. For example, the molecular formula of glucose is C6H12O6. So it states the types and different types of, atoms in a molecule, right? The numbers and different types of atoms. Is that clear? For example, the molecular formula of methane is CH4. So it shows that it contains 1 carbon and 4 hydrogen atoms, right? So again, the molecular formula shows the number and types of different atoms, right, girls? Is that clear?
Yes.
Okay. And so now other objective of this chapter is that how are you going to deduce? So Anya, did you get with the molecular formula?
Yes.
Yeah. For example, like molecular formula of water is H2O. So again, how are you going to deduce? How are you going to define? It states a number and types of different atoms in one molecule. Okay. Now, so sometimes they're just going to give us a diagrams and they're just going to ask to deduce its formula. Okay, from the diagrams as you say. So for example, like if this displayed formula of ethane is given, right? So you have to deduce its molecular formula. So how are you going to deduce the molecular formula? you will say that you are just like in exam also they are going to ask that say the molecular formula. So just check which elements are present, right? So it contains carbon and hydrogen. We will write down state the types. So the types of elements are carbon and hydrogen. Okay, right? Then the next is to count the number of atoms. Like how many carbon atoms are there? 2. How many hydrogen atoms are there? 6. Right? So this is C2H6. Right, girls? Did you get it?
Yes.
So you could, deduce the molecular formula from the given diagrams, from the diagrams, right? I'm going to give you one example. You try to deduce the molecular formula of this compound. Okay. So now, how do you know that you are going to write on carbon first and then hydrogen? Usually we just write down carbon first and then we are going to write on hydrogen and then we are going to write on oxygen. Otherwise, if you're writing in any of the order, like examiner just accepts it. Okay. So do not worry about it. I'm going to write down the display formula of an organic compound. So you try to deduce its molecular formula. Okay. This is oxygen. Okay. Try this. Otherwise, we are just going to discuss, right? So we will see which elements are present. It contains carbon. It contains the types of elements. So that it contains carbon, it contains hydrogen, and it contains oxygen. Right? Then the next is to count the number of carbon atoms. How many carbon atoms are there? 2. How many hydrogen atoms are there? There are going to be 4 hydrogen atoms, right? 3, 4. And how many oxygen atoms are there? 2, right? So the molecular formula of this compound is ethanoic acid. It's a compound you'll also be doing in organic chemistry this. So molecular formula C2H4O2. Take it, girls. Did you get it?
Yes.
Should I give you one more example or it's clear? Anya, Ambreen, and Tuba.
It's clear.
Okay. What about rest of you, Anya and Ambreen? Did you get it, Betty? Anya?
Yes.
Okay. So now we're just going to go to the next verse. That's going to be the empirical formula. Have you ever heard about empirical formula, Bachu?
No.
No. As an empirical formula, but again, we will be, knowing its definition, and also, like in the next classes, we'll also be, calculating the molecular and empirical formula. But right now, we're just discussing their definitions, right? So, what is the empirical formula? It's going to be defined as the simplest. Let me just write down its definition and I'll explain it. Simplest whole number ratio of different atoms or ions in a compound. Right? So what is the empirical formula? It's the simplest whole number ratio of different atoms or ions in a compound. As for instance, like I said that, which that the formula of molecular formula of glucose was C6H12O6. Na? So this was a molecular formula which shows the types and different atoms present in a compound. Say it. Now, if I'm asking Betty that what is the empirical formula of glucose, right? So that is going to be the simplest whole number ratio. Like, can you simplify it further? Yeah. If you just divide it by, 6, we are going to get C1. You do not write on 1, right? H2O, right? So the empirical formula of glucose is going to be CH2O. Right, girls? Are you getting it? Between Tuba and Anya? Hmm?
Can you explain again?
Yes.
Sure. Take it. The empirical formula is the simplest whole number ratio, right? Like you just see that. Can you just simplify these numbers, right? Like here we have 6, here we have 12, here we have 6, right? How could we simplify this, right? Like this simplest whole number ratio. So if I just divide these all by 6, right? So what will I get? I'll get C1H2O, right? So CH2O is going to be the empirical formula. Simplest ratio of four numbers, right? Wait, I'll give you more example. Now see, Betty, I have C2H6. Now, do let me know, can I simplify this further? This is a molecular formula. Can I simplify it, Betty? I'm bringing Tuba and Anya. By any number, can I divide it?
Yes.
Yes. By what number I can divide to simplify it by?
2.
Right? If I
2.
divide it by 2, Betty, so I will get what? CH3, right? So this
Yes.
CH3 is said to be the empirical formula, and this C2H6 is the molecular form. Right, girls? Did you get it? So empirical formula is the simplest ratio of whole numbers, right? Whole number ratio. What if I said both of the numbers are even now? What about methane? I've seen methane molecular formula is CH4, right? Now let me know, girls, can we simplify it further, Betty? What should be its empirical formula? Can I simplify it further? No, you know? Here we have 1, here we have 4. So in that case, the empirical and molecular formula will remain the same. Okay? In other words, we can say if we have even and odd numbers, so we cannot simplify it further, right? We can only get the, empirical formula in a compound if we have even numbers. Right, girls? Tuba, Amreen, and Anya, are you getting it?
Yes.
Do you want to note down anything from here, or should I erase the board? I'll give you more example. You just try to predict, okay? Should I erase it?
Yes.
Okay. Now see, Peter, let me know, are we going to have C3H8, right? Now let me know, Peter, this is the, molecular formula of propane. Are we going to have same or different empirical formula? Can we simplify it further so that we can get the whole number ratio? Is it possible to simplify it, Peter? Anya, Tuba, Amreen?
No.
No, है ना? In words, we can say if we have even an odd number, right? So in that case, the empirical and molecular formula will remain the same. ठीक है? Right? Now let me know, बच्चों, about C2H4. This is a molecular formula of ethene, right? What should be its empirical formula, girls?
CH2.
CH2, right? Anya and Amreen, are you getting it, Betty?
Yes.
Okay, so it's going to be CH2. So now, but there are proper, like for some compounds, we can just simplify it, right? But there are the steps to calculate the empirical and molecular formula, right? We'll be doing that. Let's move to the next one that we are like, that's, the objective, writing the ionic equation, word equations, right? Do you want to revise that, writing chemical equations, or should we move to the next? I'm bringing to Ben Anya. Should I revise word equations and chemical equations and ionic equations? Like how we're going to write down construct the chemical equations. Is that clear? So we could move to the next.
Yeah, sure.
Okay. So this is, what does it mean, girls? Can anybody tell me what is the meaning of this symbol? No. Okay. This is the relative atomic mass, right? This is the relative that you're going to relate it, relative atomic mass, right? And how are you going to find out the relative atomic mass? Actually, that is the mass number, right? But why it is said as relative atomic mass, right? And its definition also should be, known, right? So let me, explain it a second. I just have to, copy a diagram over here. Okay. Now see here is right. So now see if you just wanted to, buy 1 kilogram of apples, right? So here they're just going to place 1 kg weight, and here they're just going to, place apples. So this balance is going to be, at the equilibrium, right? They are going to be the equal weight, right? So we are just going to measure the mass with that weight. So if I'm just going to place here carbon 12, right? What's meant by carbon 12? The carbon having isotope, like having, 12, right? Its mass number is going to be 12. I'm going to keep carbon 12 over here. And here, I'm going to keep, what is meant by carbon 12? How are you going to measure this? That means there are going to be 12 units of carbon, right? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are going to be 12 units of carbon. So carbon 12 means there are 12 units of carbon. That is going to be the standard, okay, to measure the mass of carbon, right? So this is, if you're just going to keep this as standard, carbon 12 is standard. And if I'm going to measure the mass of sodium, right? Like mass of sodium atom, I will find that the mass of sodium atom is going to be 23, right? Now, this 23 is going to be measured, it's going to be compared with carbon 12 units. Okay? So this is known as relative atomic mass, right? Like you can say that the relative atomic mass of sodium is 23, right, BT? Why it is said to be the relative atomic mass? Because that is compared with carbon 12. Okay, like 12 units of carbon, they are just going to compare that how heavier or how lighter it is. Right, girls? Do let me know till here. I just want to get the response from you, then I'll move further. Are you getting it?
Can you repeat once more?
Yeah, sure. See, the relative atomic mass is an average mass of the isotopes of an element, right? Compared to carbon 12. Carbon 12 is the standard, right? From which you are going to compare, right? So carbon 12 is set as a standard, and you are going to, take out the relative atomic mass of different elements comparing with carbon 12. Okay? So therefore, it is known as relative atomic mass. Anya, Tuba, and Amri. In the periodic table, you might have seen mass number. Na? Mass number of sodium is 23. Mass number of oxygen is, 16. Mass number of sulfur is 32. Okay? So what are these mass numbers? When they're asking us to calculate, mass number, we say there's a total number of protons and neutrons. Okay? But when it says what is the relative atomic mass, how they have worked upon its calculations? How did they find? So they have found the mass of these elements compared with carbon 12. They just have compared its mass with the carbon 12. PPT. So therefore it is known as relative atomic mass. Okay, Anya, are you getting it now?
Yes.
Okay, again repeating. That is a bit difficult and like theoretical one. Na? Like, okay. So that's an, we can say that. So remember, we just calculated the relative atomic mass. That's going to be the average isotopic mass. Na? So we are just going to, whenever you're going to define, so I'm just going to write down its definition, then I'll again come to its, explanation, right? So let's write down its definition. What is the relative atomic mass? Although it's not being asked in IGCSE or O levels, its definition, but that will be asked in A levels, right? But you should know what is an average, relative atomic mass. So that's as the average. So it's readable, average mass of the isotopes. Isotopes. An element. One thing. That's given. Good. Carbon 12. Okay, not of, that carbon has other isotopes as well. So actually, that is going to be compared with carbon 12. Right, girls? Just review it and please answer if you have any question.
Miss, can I just quickly go and come back?
Sure. Let me answer that. Yeah. All right. Ambreen and Tuba, Beti, did you get it? What's in relative atomic mass? It's an average mass of
Yes.
the isotopes of an element that we did in, calculating the relative abundance, right? And then it's going to be compared to 1/12 of the mass of an atom of carbon 12. Okay? Right? I think we haven't done atomic structure together. Have we done that? We did second chapter, no? Right? So relative atomic mass can also be calculated by the average mass of isotopes, right? And then it's going to be compared with 1/12 of the carbon 12 atom, right? Should we move to the next? And how are you going to get the
Yes.
atomic mass, Betty? You're just going to see the periodic table, and whatever is a mass number is the relative atomic mass, right? Like the relative atomic mass of fluorine is 35.5 because they have different isotopic abundance, right? The relative atomic mass of, sulfur is going to be 32, right here. So it's an what do you say? What is the relative atomic mass? It's an average mass of the isotopes of an element compared to 1/12 of the carbon atom or compared to carbon 12. Okay? Let's move to the next thing that is MR. Right? Have you ever heard about MR?
Yes.
What is it, Tuba? What is MR?
Relative molecular mass.
Very good. So relative molecular mass, right? Great. Relative molecular mass. How are you going to define a relative molecular mass? Or how are you going to calculate it? Now see, BT, like if you're going to talk about an element, we're just going to talk about the relative atomic masses, right? But if we're going to talk about a compounds, right? The compounds like water is a compound, right? Carbon dioxide is a compound, glucose is a compound, right? Ammonia is a compound. So when you're going to calculate the masses of the compounds, we're going to say that relative molecular mass. Okay? And how are you going to, define it? So that's going to be the sum of the relative atomic masses, right? So we can say the relative molecular mass is the sum of the relative atomic masses. Okay? Anya, are you back, BT? Yes, not here. All right, so the relative molecular mass is the sum of the relative atomic masses of the elements present in a compound. Right here? Is that clear? Achha, BT, what about the relative formula mass? Amreen, Tuba, do you know? Anya? Anya is still not here. Okay. What about the relative formula mass? What is it? Relative formula mass. What is the relative formula mass? Anybody knows about it? This is also between the relative molecular mass. Okay, but when you're calculating the mass of ionic compounds, we say this MR as relative formula mass. Okay, again repeat it. When are we calculating the MR of an ionic compound, we say this as relative formula mass. That is going to be the sum of the relative atomic masses of the elements in the compound. Okay, but for the ionic compounds, we just write down this term as relative formula mass. And for covalent compounds, we say this as relative molecular mass. Okay? And bring Tuba and Anya. Did you get it?
Yes.
Let's see, like, how are you going to calculate it? We're just going to give some examples. Like water is going to be the relative molecular mass, right? It's a covalent compound. We will calculate the relative molecular mass for carbon monoxide, covalent compounds. We will calculate the relative molecular mass of, ammonia is also a covalent compound. But if I'm calculating like MR of sodium chloride, so sodium chloride is an ionic compound, you know? So what did I say? It's symbol will be same like MR, but how are you going to study? How are you going to, pronounce it? We're just going to say that this is going to be relative formula mass. Okay? I'm being Tuba, Anya. Are you getting it, Peter?
Yes.
Right? So let's do one thing. We're just going to rejoin, okay? And then I will just be giving the examples that how we're going to calculate the relative molecular masses, okay? And that also comes, simply in MCQs as well, the correct, MR of the compounds, right? Let's rejoin this, right?